Rackspace recently acquired Anso Labs, which builds the private cloud for NASA and other things. And they're really tightly interwoven in the OpenStack world. And I wanted to get a lot more detail about what that is. Who are you?
Sue Choi, co-founder of Anso Labs and Chief Operating Officer, COO. I'm really looking forward to helping Rackspace put in their support business within the private cloud.
And who are you?
Jesse Andrews. I co-founded Anso Labs to work on building NASA's private cloud, and then we took the work we did and open sourced it. I lead the technical side of our business, and have since then started working in the open source community, OpenStack community, and really collaborating with all the people at Rackspace and Citrix and other contributors.
Cool. Just for people who are watching this that are still not quite up to date on what cloud is and what private cloud is and what a public cloud is, can you just explain what Anso Labs does and maybe put it in context of what is cloud computing?
Sure. Do you want to take that one or you want me to?
Sure, I'll start. What we do is we work on orchestration of lots of virtual devices. And so what cloud is about doing is automating a lot of the tasks that you would normally have to do when you're installing a system. Like, so if you're an enterprise, you have to go through procurement, you have to go through billing, you have to go through chargebacks, all these things. And then you have to do the actual deployment of the system and installing the OS and setting it up and setting up on your networking and connecting it and controlling who has access to what. And so what private clouds allow you to do is apply these same sort of tools and methodologies that you apply to public clouds, such as just writing a little bit of code or a declarative block that sets up your cloud infrastructure. And based upon some text that you could version control and you could share, you can define what the topology of your infrastructure needs to be from a user's point of view. Okay. And so it takes a lot of the problems of setting up infrastructure that's the same for everybody. Like, no matter what you do, like no matter what department you're in a company, you have to buy the servers, you have to plug them in, you have to connect them to the network, figure out backups, all that fun stuff. And that's the same for everybody. So have a core team that does that, or have the software do that. And then you do the things that are unique for your business or your needs. We started Anso Labs in order to really come together and provide sort of like open source, take some of the things that have been created in the open source community and apply them to NASA's needs. NASA has some interesting use cases in the sense that they have missions that have problems and blow up on the launch pad. They have missions that are amazingly successful and run for years. And so when you talk about elasticity and your computational needs, NASA is an amazing place to try to help them with that, because each mission is going to have this really dynamic need, and it could be like a satellite that orbits, and every 24 hours, there's just one dump that has this huge data set. Then you want to process it, and so launch a lot of compute to process that data, and then when you're done, return it, and so another project or mission could use it then.
That mission could be anything from the wind tunnels to the shuttle launches to a rover on Mars to
the Gulf oil spill, for instance. I mean, that's interesting, right? So when you think of NASA, you think of things out in space, but honestly, they do a lot of work within the Earth sciences for the planet Earth. So for the oil spill, for instance, they had a plane that flew over the oil spill every day, and it had an amazing spectrographer that was attached to it, and it would just bring back just tons and tons of data. But what do they do? How do they store it? How do they process it? And show the difference between the oil spill one day ago to a week ago to a month ago. So all of that needs to be housed somewhere and processed. Yeah. Without the cloud, they would have to go out and spend months of trying to build that infrastructure to actually process that data. So that's a perfect example where a private cloud works really well. And why people choose private cloud versus public cloud are obviously your performance requirements and IT security. People want to have their cloud within their own backyard, within their constraints.
Within their firewalls.
Their firewalls, within their networking schemas, within that type of structure. Because one, performance for a lot of organizations, they're not seeing the results they want to out there in the public cloud.
Yeah, so they haven't quite bought into the Google world where you're going to put your emails up on Gmail and put your spreadsheets up on Google Spreadsheet, right?
Especially if you're a company, think about it. If you've got the secret sauce, right? You want to keep that secret sauce contained in the smallest footprint possible. The best way to do that would be going private cloud versus public. But there are some great use cases for public cloud.
Yeah.
For instance,
and hybrid as well.
And hybrid, yeah, absolutely.
Now, what's hybrid?
Oh,
hybrid means writing an application so that it can run on both a private cloud as well as a public cloud, or even like multiple public clouds. And so the idea is that, and that's what, when you talk about private clouds, right now it may be that for security reasons or performance reasons, it's important to run it, or it may provide a differentiator for your business to run it internally. But long term, it may be that public clouds work for you. And so a goal of OpenStack is to make it so that it's a stack that you could run inside of your private cloud, or Rackspace can run it, or they're actually working with all the other large companies in order to allow other service providers to offer it. And so that way you could take your work and transfer it even more easily between all these different clouds. And so hybrid is that general concept of being able to move between clouds. And right now there are companies like RightScale and other companies like that that add that capability, but it's there. You then write to the RightScale API, and so by hoping to add it at more of the API interface and have sort of more standards ways of interacting with clouds, it hopefully makes it so people can move up the value food chain in providing those higher level concepts of orchestration between multiple clouds.
Even a single database could have pieces all over the place, right? If I have a context database inside my company and it has salary information, that salary information I might want to make sure it never ever leaves my firewall, so nobody else ever can have a shot at getting into it.
you might have information that you've just processed on your cloud, some data within your database, right? You've just done some amazing number crunching that you'd like to share with the general population. And no one really cares until you start sharing it. So then instead of ramping up your infrastructure, what you would do is you would burst into a public cloud and hopefully an OpenStack cloud, and go ahead and there you have instant infrastructure right there for that short period of time where that information hits, well, you'll report about it or Mashable reports on it. That just brings people in droves, and then it'll die off in a couple of weeks.
If you were to describe the architecture of OpenStack to somebody who doesn't know what OpenStack is, can you sort of draw a picture on our screen of what OpenStack's architecture is and what the pieces are?
Virtual servers, so computers, give me some networking and some storage. And so I like to think of it like you could get a server, which is kind of like your laptop, but it has no screen and it's really serving a website request or something like that. And then if the amount of data you need to store grows, you could provision automatically just by typing a single command in, and a new 100 gigabyte hard drive or 2 terabyte hard drive appears and gets attached to that virtual machine. And so now you have more room for storage. And now let's say you need to, you're getting attacked, or you're getting attacked, and so you could just type, or you get on Oprah, and so you could really quickly type a few commands in again, and it will replumb the networking, which is how you connect all these machines together. So it's really just those three main. That's the basis that you build a lot of other services on top of. Is give me computers, give me storage, and give me networking, and then you can piece those together.
Very cool. And what are the pieces then that you work on of those pieces? Sure.
So what we created for NASA was called Nova, and it's one half of OpenStack. It's the OpenStack compute side, and it's we use a lot of hypervisors, which are things that take real servers. So you buy a $10,000 or $20,000 server that has 100 gigabytes of RAM and 24 cores and 20 terabytes of hard disk space, and it splits them up into lots of little computers for you. And so that's what a hypervisor does. It creates these little secured jails that you can't get into each other's virtual machines. And so the compute controls that sort of splitting up. It's orchestrating these machines to split up the storage and the compute and then connect them via networking. What turned out that was interesting is a lot of the problems that NASA has are similar problems that a service provider has, because they want to operate at scale, they want to be able to operate on commodity standards hardware, and so we open sourced it, and then Rackspace open sourced their object store, which it's also storage, but it's a different type of storage. Object store, what it is it's a way to share a lot of content. And so what an object store does is it keeps multiple copies on servers all around the world even. And it makes sure at all times that there are 3 or n, by default 3 replicas, and is always checking to make sure. And as hard drives are getting bigger, the size of the number of atoms that are being used to store these bits are getting smaller and smaller. And so the occasions of bit rot occurring, which can be either magnetics or cosmic particles hitting your disk, and so catastrophic data loss, which is your like you probably have a friend who's lost a laptop and they should be backing up. It's something that happens. It's a daily occurrence for data centers, and so when you run a cloud and you're in charge of that, so the cloud provider is in charge of making sure the compute and the storage and the networking is there for them, and so we have to then deal with the fact that failures occur and plan for it.
Yeah, companies are making real bets on these infrastructure systems now, right? Because you no longer are buying a data center. Usually you're buying from Rackspace a piece of a server or a piece of a data center.
When you're small and growing, that level of abstraction, what the actual physical hardware underneath of it, isn't that important. But what's really interesting is that running your own private cloud could also be important, because it may be really important to you. If once you get to have thousands of servers, still having those cloud semantics of being able to separate the process of buying and physically installing the servers and then allocating their usage, separating those two things to the application team and the operations team. Yeah. And you may want to use virtual machines in this sort of model, but only still run a single virtual machine per server. And so that way you get the advantage of sort of cloud moving things around and all that fun stuff, but you still get to take advantage of the full hardware. And so at different scales, you start paying attention to different layers of abstraction.
Private cloud is a little different, because you're not really buying external server farms anymore. You're maybe putting infrastructure in on your existing server. How do you decide?
Yeah, so one of the first questions is that, one, what will you use the cloud for? Are you looking for data center automation, which Jesse sort of alluded to when talking about just how do you manage an infrastructure of hundreds of thousands of nodes by yourself, which that might not necessarily be your core expertise. Your core expertise will be running a data center versus running a cloud infrastructure, which is completely different, because now you have to understand the software layer that's associated with it, and the orchestration layer, and then and the purchase of hardware just for those use cases that are associated with it. So those are interesting things. But when we talk to clients out there that are really interested in deploying their own private cloud, one has to do with just on-demand power. They don't want to wait in line, and they don't like the limits that private cloud gives them. They don't want to call anyone and ask, I need 50 more virtual machines today. They just want them now. Another part too is what we talked about earlier, was from the IT security aspect of it. Say there was, they get hacked, and they want to do forensics on that server, that actual physical machine. It's unclear if the commercial providers will actually give you that, so you can actually run the forensics on it. Like, will they go out to their data center, rip out that hard drive for you, and FedEx it to you? And what is the chain of custody that's associated with it? Especially when we're talking about an international kind of hacking incident.
For the person who wants to run their own data center inside their company, they're down in the first floor of the basement, they have 600 machines doing something. Does OpenStack help them see what's going on in that data center and manage it and run it?
So the statistic out there is that every server right now is utilized only 15%, but it's always on. So can you just imagine just the power and the waste of that? And a lot of people, unfortunately, buy servers that are too big. Can you imagine just managing your entire resources? So of those 600 servers, of using OpenStack to actually sort of manage, and you can actually see exactly what is going on within your entire data center with one easy set of tools.
Does it show you like like an Excel spreadsheet almost in live view?
There's lots of API integration and integration with tools, like a lot of other open source projects such as Ganglia, Nagios, and
What are those?
Nagios is kind of a standard way of nagging you when your servers are having issues, and Ganglia is a clustering sort of performance system that will pull in like how much utilization you have on disk and CPU and memory and all that, and aggregate it up into cluster and then cloud level. It's things that have been implemented over the last decade to support larger systems, and that's cloud isn't it's taking what has been happening so far and adding more APIs on top of it. And so it's trying to, like, in general, and this is kind of why cloud is a little hard to define. It's just taking existing systems and trying to turn it from meatware to software. So you don't have to have somebody go and do something for you, automate that. And so I think it really ties into the DevOps philosophy, which is, DevOps is all about saying that sysadmins are actually some of the most important people. It's not about them logging in and fixing servers by typing in commands. It's about them setting policies and using things like Chef and Puppet to automate those.
What are those?
So Chef and Puppet are two popular open source tools for taking files about configuration of a server. And so you don't have to like go in and right click on menus and say set this up to do backups here or there and configure the printer. You write some code that then specifies what the configuration should be, and then they both, they're a little different in philosophies of how it happens, but it then gets applied to these servers, and so then you have this sort of configuration that is then managed for you, but you as the sysadmin are more setting the policies. Yeah. And so it's a higher level, and so some people think it's the whole DevOps thing was originally like saying that no, let's take stuff away from the sysadmin, but it's more let's take what they do and build that into every layer of what we're doing, our software, our configuration, everything.
And that's the cool thing about OpenStack, is that that's a huge ecosystem of what we just talked about. So you have OpenStack as in just the core code of Nova and of Swift, and so that's the compute and object store. But then you also have an ecosystem of tools, monitoring, of configuration management. And there's a lot of companies that have joined the OpenStack movement because, one, they believe in OpenStack and they believe in open source. And then it's opening doors for a lot of other corporations out there to even just talk about their product and why it's important to the cloud ecosystem.
So why join Rackspace?
So we've been working mostly for NASA, but also helping other people and with their cloud needs. And from the first time we met Rackspace, it was like everything, a lot of what their decisions about how they did development, about how they did networking, like it was down to, wow, you use the same network switches as we use in our cloud. And so over the course of working in the open source community, got to know a lot of their developers and their leaders, and really liked the way they operated, the fanatical support, the really caring about the customer and their use cases and their problems. And that's why we're doing this, is we came to NASA to help push NASA to allow them to do even more. We want their scientists and researchers to be able to do science, not do system administration. And so Rackspace has that same sort of model, and it seemed like a great fit.
What's next for your team?
Jumping into Rackspace and joining the new business unit that's called Rackspace Cloud Operations, or Rackspace Cloud Ops. We're really excited about that. One is that we'll be offering training and certification of OpenStack, everything down from the API to how do you actually manage your cloud, like now what? And then also training their users on how to use cloud and migrating and growing that ecosystem. The second piece of it is actually implementing OpenStack at different organizations, albeit the Fortune 100 to service providers. And we're really excited about that, because the more reference implementations that we have of OpenStack, the better the code gets. Yep. Yeah, the more requirements we'll get.
The real problems.
Exactly.
Yeah.
And the third is support. So what Rackspace is famous for is its fanatical support. So can you imagine taking that and having Rackspace's fanatical support actually supporting your cloud, your private cloud? That will be absolutely amazing. That's a really, really strong service offering. So that's what we're really excited about doing.
How can people integrate and get involved in the OpenStack movement?
There's, as we kind of talked about, there's layers, whether it be coding, talking about what their use cases are. It's amazing. Just like try it out, kick the tires, share on the mailing list or in IRC what you find. There are people doing amazing things like taking clusters of GPUs and controlling them with OpenStack, and we had no idea until some guy was like, "Yeah, it works for it works for that," and share that sort of idea. And we designed it to be very hacker friendly in the sense of pro hacker, the wanting to go in there and tweak it and bend it to your own like your own requirements. And we want it to be fun to develop. And so if you're a developer, we hope that you can download it, try it out, and then share it with us.
And there's openstack.org. And you don't actually have to be a developer either. Testers, QA are also needed. People that love documentation. I would love to have you. Would love to talk about use cases.
Very cool. And you guys are on Twitter as well, right? Twitter.com/OpenStack.
Yep.
Thank you so much for giving me a tour around your world.
Thanks.